Okay, so is it fine now? Am I audible to everyone?
Yes, yes,
Yes,
Okay,
ma'am.
yes, ma'am.
so I'll just share my screen and then we'll start with the doubts of session one, the week one. I hope my screen's visible.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Ma'am, is it just a doubt session, or as we discussed
Yep.
with sir yesterday, we'll also be covering set theory?
I have not been informed about covering the topics that are left in week one, but other topics that have not been covered yet. Am I audible?
Yes, ma'am.
Yes, ma'am.
Yesterday we
ma'am.
were having a summary session, and today are we not going to continue that? Is it just a doubt session?
It's supposed to be a doubt session, but if the summary was not done yesterday, then we'll have to check. Just give me a minute.
There were some topics left.
We were completed with relation.
Yeah, okay. Give me 1 second. Okay, so I think the intersection, union, and the set theory part, some of it is left, right? So we'll just cover that part first, the formulas and everything. Then we'll probably do a question on it, and then we'll start with the doubts. Okay, so we'll first start with what's a union. A union of sets, which is, let's just say you have two sets A and B. So the union is this thing. This is your universal space. Then this is, say, set A and this is B. So this whole thing, which contains both the sets, right? One and then the second one also taken with it. This thing is called the union of two sets. And then we have the intersection part, where it's, if we have to write like what it means mathematically before moving to the intersection, This just means if you say X belongs to A union B, you mean X belongs to A or X belongs to B, which means either X is in A or it's in B. And then we have the intersection. The intersection is basically this. If you sets A and B, then the intersection is this part. And mathematically, it means when you say that X belongs to A intersection B, audible, right?
Yes, ma'am. Yes, ma'am.
Yes,
Okay.
ma'am.
This means that X is in A and it's also in B. There's a difference between and or. So when you say X is in A, you mean that X is either in A or it's in B. It doesn't have to be in both the sets. Even if it
Excuse
is
me,
in one
ma'am,
of these
you're
sets,
audible,
yes.
but there are disturbances.
What
No,
kind
ma'am.
of
No
disturbance?
disturbance. Ma'am, you speak. If you speak loudly, then there is no disturbance.
No, ma'am, your voice is very clear.
Yes, ma'am. I think you are clear.
So, if X is in if X is in A,
Your
you
voice
tell
is
me that
clear,
means
but not very loud.
So, ma'am,
I'll try
keep
to.
keep mic in where
Yeah,
at
okay. I'll try to speak a little louder. Is this fine now?
Yes, ma'am.
Okay.
little bit
So
more, ma'am.
let's say you have your X in A union B. We were discussing this thing in mathematical terms. This is in the Venn diagram form. This is called the Venn diagram. I hope you're familiar with the term Venn diagram. So this is in terms of Venn diagram, and this is the mathematical definition of what it means for an element to be in the union of two sets. So when you say that X is in union of two sets, it basically means that X is in A or it's in B. So it doesn't have to be in both of them. If it's in both of them, then also it's in A union B. If it's in one of them, then also it's in the union of both of the sets. And then you have the intersection. So if X is in A intersection B, that means either your X is in A or it's in, so it has to be in both of them. If it's in intersection, then that means X is in A and it's in B both. So it's from here you can see it's in A. This is that segment. So the element has to be in A. This is where it's in A, and this is where it's in B. So it's in both the sets. It has to be in both the sets. Then is when you say that it's in the intersection of both of the sets. That's what it means by union and intersection. This is of two sets only, but you can take it for more than two sets and for a lot of sets. That's fine. The definition part clear, and then we have the very basic formula for A union B, which is A and then the set B,
Ma'am, NA
or
plus
you can
NB.
just say, yeah, that's the number of elements in A. It's basically what we mean by this thing is there's nothing defined as a sum of two sets, right? So it's basically, okay, let's just write N only. And then you just subtract the intersection of it. So even if you don't take the number here, this is for N is for the number of elements in A union B. That works fine too. But for that, you'll have to define what this plus is. Let's just not get there. Let's just stick to this. This is it. The number of elements in A union B is the same as this thing. And then and there's a clear difference between the entire set that you've been given. So this is your entire thing, which is called the universal set. And then it's sometimes not equal to A union B. There are sometimes elements that are not in A and they're not in B. They're not in both of these two sets. And then for 3, you have this thing. These are the two formulas that you're supposed to use in your questions, in the set theory questions that are there. That's all. That's the part that was left. Besides that, we can, while discussing the questions from assignments, we can discuss questions that make use of this information that we discussed. So, is that all right?
Yes,
If you
ma'am.
have questions from this
Ma'am.
part, you can ask it while we're discussing the doubts. So we'll start from assignment 1 and then we'll move forward. So, does anyone have any doubt in the first assignment? The first one?
In practice set or as activity one?
Yeah, the activity one. First
No,
activity.
ma'am.
We're starting from there. So, does anyone have any doubts from the activities?
No.
No, ma'am.
No doubts from the activities, all right.
Ma'am, I have shared one doubt from activity 6 in the chat box.
Okay. You can just tell me the question number. That's better. Just tell me the activity and the question number.
Question 7, activity 6.
Okay. So, this is the question, right?
Yes, yes.
Two finite sets A and B, and the total number of subsets of A is 56 more than the total number of subsets of B. The total number of subsets is, it's basically the cardinality of the power. Let's just say you have a set A, and then this is the power set of A. That's the total number of power set of A. Basically, is the collection of all the subsets of A. That's the, you've been asked, you've been given that the this thing is, let's just call it as A only. For simplicity, we're taking this thing to be A, or let's take it to be small. So the total number of subsets of A we're taking to be small a, and the total number of subsets of B we are taking to be small b. And they say that it's 56 more than the total number. This is it. No. Yep. This thing is or wait.
2 to the power n.
So the total number of subsets is 2 to the power n, where m is the number of elements in A. So in A, you've been given okay, but let's just change the notations only. Let's just take the cardinality of A to be okay. We'll just denote the cardinality of A by capital A only, and the cardinality of B by capital B only. This will give you this thing, and this is 56 more than this thing, where this is the cardinality of A.
Where
cardinality of
capital
A.
A.
Yeah, this is for simplicity, we are denoting the cardinality of A by capital A only, and cardinality of B by capital B. This is it. This is what you've been given, and you just need to check which of these pairs satisfy this equation. That's all. So you can't possibly try to solve this the values of A and B from here, but you can definitely try to test these values. So if you will put, let's just check for the first option, it's 6, 3 here. So 2 to the power 6 is, I guess, 64 it is. And then 2 to the power 3 is 8. This holds, right? This holds. So this can be a possible pair for the cardinality of set A and set B.
Ma'am, could you
And then
please elaborate more about cardinality from the scratch? I could not really clear the whole
okay.
concept of cardinality.
Cardinality means the number of elements in a set. So if you have A, usually you shouldn't be, if your set is noted by capital A, you are not supposed to use the same notation for the cardinality. This is what you denoted by. But to do the question quicker, I just use the capital A notation only. This means the number of elements in set A, right? And this means the number of elements in set B. So if we're taking this to be small a, and let's just take this to be small b. And
Ma'am,
then there is something called, yes.
what do you mean about tail notation? It is mod, I think.
What? This is
Tail
how you denote the cardinality of a set. The cardinality of a set is noted by this thing. And the cardinality of B is noted by this. Cardinalities are denoted. For sets, you denote the cardinalities in this manner by putting the mod. Is that all right?
Yes, ma'am.
Okay.
Yes.
Yes, ma'am.
So I hope the cardinalities part is clear. Then we'll discuss the power set part. So power set is basically for A, let's just say you have two elements, A and B. Your power set is basically the collection of all the subsets of this. So it's the first one will be the empty set. Then you have the singleton A, singleton B, and then you have AB. So it's like the possible subsets of, it's the collection of possible subsets of A. That's what power set is. So this is the power set of A, right? And the number of elements in power set of A, the cardinality of power set of A, that is the total number of subsets of A, right? That's what cardinality of power set of A is given by 2 to the power n, where n is the total number of elements in A. So if A has n number of elements, then power set of A has 2 to the power n number of elements. We can discuss how we get to this formula, but we don't need to. Is it all right?
Yes,
Do you
ma'am.
want me to discuss how you get to this formula? How do you get the number of?
Yes,
is it all
ma'am,
right?
please.
Yes, ma'am, please,
please.
ma'am. Yes, ma'am.
Okay. So basically what happens is that let's just say you have n elements. This is first element, this is second element, this is third element. So now you have two choices. What you do is to make a subset, either you keep an element or you don't keep the element. So you have two choices for every element. Either you keep it or you don't keep it. For this one also you have two choices. Either you keep it in a subset or you don't keep it. So same is the case for every element that's there. That's why you have two possibilities for every element. And there are n number of elements, right? So this has two possibilities. Either you'll keep it or you won't keep it. Then the other one has two possibilities as well. And then the other one has, that's why you get, so this is done n number of times. That's why you get 2 to the power n. Number of sets you get is, let's just say you have a set, then either you'll keep this element or you won't keep this element. So it has two possibilities. Then for this as well, either you will keep this element or you won't keep this element. This again results in 2. That's why you have 2 to the power n number of subsets. Is this fine?
Ma'am, suppose for n1, if we keep it, then how many subsets we'll get?
Just say you're saying that if you're certain that you want to keep this thing, right?
Yes, ma'am.
And the other ones you're not certain about. So what you do is
Okay.
now you only have one possibility here, so you do one, and for the rest there are still two possibilities for each of them. So this is now n minus one number of times.
मैम इस मेथड को क्या कहते हैं मैम?
What method?
Ma'am, the method you explaining, actually you derive the formula.
I don't think it has a name.
Ma'am, actually, what I'm asking is, suppose there are 5 elements, okay, and
To the power 5.
like n1, n2, n3 up to n5, and for n1 we have two choices, right? We can either keep it or we can remove it. So suppose we are keeping it, like in our subsets. So by keeping it in our subset, how many subsets we can get out of that?
That's the answer. That's what I gave you. It will be 5 minus 1, so you'll repeat it. It's 2 to the power 4 then. If you had 5 elements and you've decided that you'll keep one of them,
Okay,
then
okay,
this is the number of subsets you get.
मैम अगर
okay,
मैम
okay,
अगर
okay.
possibility होगी एक एलिमेंट को रखने की, तो उस तो 3 to the power n हो जाएगा. I'm just asking you.
What's your question?
Ma'am, suppose n1 has 3 possibilities.
Okay. No, it doesn't
So
have to.
the
There are
formula.
only two. Either you keep it or you don't keep it.
Okay.
That's why we have two possibilities. In
Okay.
a subset, when you're making a subset, either you keep one element or you don't keep that element. So there are only two
Okay.
possibilities.
Okay. Ma'am, if n1 has only one possibilities, then what happened? Then at 2n n minus 1, what actually happened?
Okay, so the question was that if you
Okay.
fix one element, let's just say you have 5 number of elements, and you've decided that you need to find the number of subsets in which this first element is fixed. So each one of them has this first
Ma'am,
element.
what can you repeat again? Ma'am, your voice is lagging actually.
The question is if you have 5 number of elements and these are numbered n1, n2, n3. Let's just say you have elements n1, n2, n3 till n5. And you need
Okay.
to find the number of subsets that have this element and rest we're not sure about. So you just need to find the number of elements that has this element, n1 element. So what you do here is, you know that for this element you have only one possibility now, because you'll have to keep it,
Okay.
right? You don't have the other
Okay.
possibility. You can't discard it. So n1 you have
Okay.
to keep, and for the other ones you have possibility. So what you do is 1, because this has only one possibility, and the
Okay.
other ones still have 2 possibilities, so 2. Then for the third one you have 2 possibilities, fourth one you have 2 possibilities, and fifth one you have 2 possibilities. So you get 2 to the power 4. So this is the number of subsets that you will get, where n1 is there in that set.
Ma'am, can you generalize this formula?
This is the generalization. If you have
Ma'am,
okay,
so
if
ma'am,
you
we are in this. We are only keeping one set, and the rest are we are not keeping it. So that's why the two to the power 4.
2 to the power n minus 1, I think. I'm correct?
if you're certain that this element
If
is in the sets, or you're certain that this element is 100%, let's just say you have to figure out the number of subsets such that n1 is not an element of those subsets. This is also the same. This will also be 2 to the power 4. Or if you have to decide number of subsets such that n1 is an element of those subsets, that's also 2 to the power 4. Because what's happening is you're restricting the choice for n1 now. If earlier you have 2 choices, to keep it or to not keep it. Now you've only one. We do 2 here because it has 2 choices. This element has 2 choices. This one has 2 choices as well. That's why we are doing 2 here. If you restrict the choices for this, then you will only do 1 here. If you restrict the choice is for more than one element here. Let's just say you're certain that you have to keep n1 and you have to keep n2 as well. Then the number will be 2 to the power 3. Because then you will have
Ma'am,
1 into 1 into 2 into 2 into 2. One choice
ma'am,
for this
actually
one.
the formula is 2n minus 1. If we remove one element, 2n, 2 to the power n minus 1, and if we remove, if we
Yes,
discard two element, then the formula is 2 to the power n minus 2.
that's the.
Okay.
Is it clear now for everyone?
Yes, ma'am.
That's how you get the total number of elements in your power set. Power set is basically the collection of subsets only. It's nothing else. So, and in the question it says that the number of subsets of A, let's just say the number of subsets of A is this thing. It's 2 to the power A, right? This part must be clear, where small a is the cardinality of the set A, small b is the cardinality of set B. So the
So,
total
ma'am, we
number of
can
elements,
also say that the cardinality of a power set of A is the same as the number of subsets of A.
that's what a power, yes, that's what precisely a power set is. Is that okay?
Yes,
Is this
ma'am, clear.
question clear now? You can just check the options now. You don't have to do anything.
Okay, ma'am, it is clear. Ma'am, can you just say about the difference between proper subset and subset?
Okay, so when you say, let's just say you have a set S and then you say A is a subset of it. This is how you denote it. So when you say it's a subset of it, it could be equal to S or it could be completely contained in S. Let's just say you have this as S. So A could be completely contained in this. This is this case.
Okay.
When you strictly write that this is not equal, this is a proper set. When you know that A is not equal to S, and it is properly contained in S. This is what you mean by properly contained in S, which means
Oh,
that A is
okay.
not equal to S. Is it
So,
clear now?
okay. So when the case is A is not equal to S, then we can say it a proper subset.
Yes.
And we can
When you're
also
certain,
say it a subset, right?
yeah, you can call it a subset and you call it a proper subset when you're certain that it's not equal to the set
Okay.
itself.
It means all the proper subset is also a subset, right?
Yeah,
Okay, ma'am. And ma'am, one more doubt about that equivalence classes.
yes. What is it?
Uh,
Ma'am, before you move on to this next doubt, can you please once again clarify the notations for equal sets, subsets, and like proper subsets?
Okay, proper subset is this. And just a subset where you're not certain if it's a proper subset or not, it's this. This means it either can be contained in this set or it can be equal to this. This is for the equal thing. And this means that it's 100% not equal to this set and it's properly contained in it. So this is for the proper containment. This is for the containment where you're not sure. Is it fine now?
And if we don't put an equal to sign below the containment sign, then what will it be
That's
called?
also considered a proper
Ma'am,
subset.
ma'am,
Maybe.
can you take example and ma'am explain the notation like 1, 2, 3, 4 and A, B, C, D like example.
I I don't think I understand what you're asking.
Ma'am, can
Please
you
explain with
take
an
a simple
example.
example? Yes, ma'am.
With an example, that's what we did. Let's just say this is a set S. And when you say that it's properly contained in it, this is what you mean. This set A set is properly contained in S and it's not equal to S. And when you write
Ma'am,
something like
ma'am, no,
this,
no,
this
ma'am,
means,
no, ma'am, please like a numerical word or later word like
Ma'am, just
A,
describe
B, C.
an elements for A and S, and
Yes, ma'am.
then we can
Element
explain it.
3.
okay, so
Ma'am, we can take n and like natural numbers, real numbers like that.
okay. This works too, right? This is a proper subset. So B is a proper subset of A. And if you want it in terms of the numbers that you discussed, then natural numbers is a proper subset of integers. And integers are a proper subset of rational numbers. And rational numbers are a proper subset of real numbers. And irrational numbers are also proper subset of
So ma'am, there
real
is no
numbers.
difference between subset and proper subset.
Subset and power subset.
No,
What's your
proper
question?
subset.
Proper
Subset and
subset.
proper subset.
No, there is a, when you say a subset, it's, you typically write it in this manner. Where you don't, when you write this thing, you mean that this set can be equal or it can be properly contained in this, where you're not certain. But when you write this thing, you mean that you're certain that A is properly contained in S. There is a difference between, when you say a subset, you just mean a subset. You don't mean proper, improper. So it's like this. We have subset and then we have it categorized in two parts, where one is a proper subset and the other one is an improper subset. Is it fine now? So there is a difference between these two. Is it
Yes,
clear
ma'am, it
now?
is clear.
Okay,
मैम
anything else from
तो मैम जो बड़ा होता है उसे हमेशा राइट में लिखते हैं हाँ? मतलब जैसे नेचुरल नंबर आपने लिखा तो नेचुरल नंबर जेड इंटीजर मतलब नेचुरल नंबर के अंदर इंटीजर आता है ना, तो आप उसको लेफ्ट में लिखा है और दूसरी साइड में आपने रियल नंबर्स को उस राइट में लिखा है, ऐसा कुछ?
it's where this opens. So the mouth of this thing, it opens on this side. So that's where you write the bigger sign. So if you say this thing, you mean that A is contained in B. That's the notation for it. So natural set of natural numbers is properly contained in set of integers, and set of integers is properly contained in set of rational numbers. What's your doubt here?
I have a doubt in a 1 and onto function.
Yes.
Activity
Ma'am, I
11
have
and
a
question number
doubt
4.
Let's
Ma'am, I have a
do
doubt
the
in
1 on 2
activity 8.
thing. Yeah, let's just do the 1 on 2 thing first. Someone was asking about it.
Okay, ma'am.
What was the 1 on 2 doubt?
I have a doubt on a 1 and onto function question.
Which
Like
activity is it?
activity
Yeah,
11
do you
question
have
number 4.
do you have the doubt in the question itself, or it's just a
No,
definition
ma'am.
doubt or something? Okay.
No, I have a doubt in a question, ma'am.
So should I go ahead?
Activity 11 and question number 4.
This is the question, right?
Yes, ma'am.
Yeah, so what's your doubt?
I cannot solve I cannot solve it.
Okay, let's just write down some of the values first. Okay. So this is an odd number. So you'll have 1 plus 1, 2 by 2, that's 1. For 2, you'll have 1 again. Then for 3, you'll have 2. And then for 4, you'll have 2 again. So the pattern here is, if you've observed it, it's the same for F2n and F2n minus 1. Right? So if you'll put a 1 here, then n belongs to natural numbers. Minus 0. We consider 0 as well in the set of natural numbers. So this is the formula, right? If you have
Yes,
to
ma'am.
generalize this thing, this is it. So first is if it's 1 function or not. By the definition of 1 function, you know what 1 function is, right?
What,
onto
ma'am?
function.
Do you know what a 1 function is? Can you
No,
tell
ma'am, I
from
have a
here
doubt
if
in
it's a,
also.
what's your doubt
Yes.
in the
Ma'am, I
question?
have a doubt. Ma'am,
Ma'am,
I have a
it's
doubts in
one function and two function.
Okay, one at a time. Only one person will speak at a time.
Yes, ma'am.
Yeah.
Unique input का unique output. मतलब एक का एक ही होगा ये.
Someone had a doubt in this question. What was the doubt?
मैम बीच में वो बोल दे रहा है मैम आई हैव अ डाउट व्हाट इज अ वन वन एंड व्हाट ऑन टू फंक्शन आई कैन नॉट मुझे नहीं पता मैम ये क्या होता है क्लास
Okay.
में किया था मैम वाला
Okay. So one function is, let's just say you have a function from this set to a set B. Let's just say you have some elements here and you have some elements here too. So one function means that that one element is supposed to have only one image, or not. That's a function itself. So that's the definition of function that I just said. It just means that no two elements should have the same image. This is what it means. This should not happen. So if you have two different elements, they should not have the same image. These are called the elements, and then these are called the image of these elements, right? The function is from set A to set B. So what you mean is, diagrammatically it looks like this: that no two elements in set A, this is your domain, no two elements from here should have same image here. No two elements should be mapped to the same element in your codomain. That's the definition of one function. And mathematically, when you write it, it's like this: if you have two different elements, x1 and x2, and the image turns out to be same, that means the elements are also same. So what we're trying to say here is that if you have two elements and they have the same image, because that cannot happen in a one function, that's why these two elements should have been the same. Is that okay?
yes
So it
ma'am
just means that no two elements can have the same image. That's all. That's what your one function is. This case should not happen. That's why I've marked the cross. This should not happen. Every element should have only one image. That's a one function.
So, ma'am, can I ask something here?
Yeah.
Ma'am, to prove a function is 1 or not, then we can just like go by this way. Is it f of x1 equal to f of x2?
Yeah. If you see that the image of two elements is same, so what
Okay.
you do is, let's just say you have a function x square, right? What you do
Uh-huh.
is you do x square equals to y square, and if you're able to prove that x is equals to y from here, then you say that it's a
Mhm.
one function. If you're able to prove this thing from here, so from here, if you can prove this thing, which is very easy, you'll be given easy things, then you can
Okay.
say it's a one function. But this is not a one function,
Okay. Okay. Okay.
so you won't be able to prove this thing. Let's just say you have x plus 2 as your function. This is a very simple example. Then if this thing is equal, this is fx and this is f, right? So if these two things are equal, then you need to prove that your x is the same as y, and you will be able to prove this because you can just cancel
Yes.
2 on both sides, right? So you can prove this thing easily. That's why this is a one.
Okay.
That's the definition of one functions.
So suppose to disprove something, it is 1.
You
Then
don't disprove it. You just find an example for it.
then we
Like in this
can
case,
yes,
yeah,
ma'am. That's what I'm saying. Then we can just put some arbitrary number
yeah.
over there, right?
If you
Okay.
have
Okay.
to, yeah, that's what you have to do. An arbitrary number, and you just show that this is not holding for this number.
Okay.
That's all.
And any method for onto? Like this is the
Yeah, there
mathematical
is a method
approach.
for onto.
Uh-huh. Okay,
We'll
ma'am.
discuss what onto is first. Onto means that if this is your domain and this is your codomain, so you want every element here. So I hope everyone's aware that for a function from your domain to codomain, you don't have to have a pre-image for every element in the codomain. But for an onto function, you need to have a pre-image. Pre-image means this. If this is your element, then this is called the pre-image, right? What's mapped to this element is called the pre-image. So if you have a pre-image for this, someone had a doubt in the definition of onto. Is it clear?
yes ma'am
This just means that if your x, mathematically, if you write it, it's this. If your x is in, or let's just say y. If your y is in the codomain, then you need one x in your domain. You call that the function is onto. So f is onto if for all y belonging to, this is the symbol for all y, for all y belonging to codomain, you want an x, this is the symbol for there exists. So there should exist an element x in the domain such that fx is equals to y. So every element should have a pre-image.
Yes, ma'am.
I hope
I
everyone
understand.
knows what a pre-image and an image mean in terms of functions.
Yes, ma'am.
Okay,
Okay,
ma'am.
that's the definition for onto function. And to check if a function is onto or not, you just let's just say you have f, and then let's just say your function is x square plus 2. This is your function. And what you do here is, and you need to check if this function is onto or not. So you do this thing. So firstly, you will need to know the codomain, right? You need to know the codomain of this. And that's codomain changes the onto-ness of a function. Let's just say if you have this from real numbers to real numbers, then this is not onto. We'll discuss why it's not onto,
Okay.
but I'm just telling it now. And if you have this from here to R positive means positive real numbers, or I should write
Then also it won't be onto
that
if
it's
it is
not
R
onto.
Integer.
positive. It should be greater than equal to 2.
This is the thing, then it is onto, right?
Yes, ma'am.
How do you check it? One way to do it, there are several ways to check if a function is onto or not, and you will be doing it in your consequent weeks, in the upcoming weeks. So we don't have to discuss that in detail. You have an entire week for onto one function, so we won't go into the detail right now. So you just do, if you have an R here, so you take a random C, arbitrary C from R, where C is any element from R, and you test if this is possible, if the solution of this is possible or not. So this is when you will discuss, all I'm trying to say is, let's just say you have x plus 2. This is when this you will be able to do when you do the quadratic equations and all. Or because this is just 2 only, so you can do it right now. This will be c minus 2. So that's why we'll have to discuss
Ma'am,
the quadratic things here, and I don't want to get into that
ma'am, if
in
it
another week.
if it's
Okay, okay. Okay,
There are
ma'am.
definitely ways to check. If you have to discuss in context of this question, then we can discuss. This is
Hello, ma'am.
an on.
Ma'am,
Yes.
regarding the question, I am getting it quite difficult about the odd and even thing. And ma'am, also you put 1, 2, 3, 4 instead of the x. Can we put any value as per our likings, or is there any method of doing it?
So you have the domain as natural numbers. No, you can't put any value. You have to start from, okay, we include 0 as well in the natural numbers. So if you put a 0 and 0 is considered even, so you'll get a 0. So you can't put any value here. You only have to check at the natural numbers, 0, 1, 2, 3, and this is what you're getting. So this is an onto function. It's not 1, 1 clearly because there are two elements that have the same value, right? That's why it's not a 1, 1 function, but it's an onto function because every natural number has been covered. Every natural number has a pre-image, right?
Ma'am, here
Then
by
you,
analyzing
Yes,
the
ma'am.
pattern, we can say that it is onto, right?
yeah,
Okay, okay.
so I hope everything is clear till this part. We'll move on to the next doubt.
Ma'am, I
Uh,
have a doubt, ma'am.
yes,
Ma'am, in activity 8, question number 5.
Ma'am,
yes,
can you explain me the last question in the end once again?
yeah, sure.
Thank you, ma'am.
This is the question, right?
Yes, ma'am.
So you've been given sets here. You've been given B set, then a set G, with a set of boys and girls respectively. Okay, so we have this thing here. There's not a lot of things. B is set, we're denoting these things by A, R, and S. And the set G by N and H only, N and K. They say that Ramu is brother of Neha, Anil is brother of Kirti, and then Suraj is brother of both of them. So what does that mean? So by brother, if this person is brother of this is brother of this, and this is brother of these two, right? Then doesn't it just mean that they're all siblings? Is this part clear firstly? The person who had a doubt in this question, is this part clear?
Yes, ma'am.
Okay. That means they're all siblings, right? The okay. Then the question is, so you just have to, so you should have all the elements here, right? And so it just, you know that the power, so you should have your B cross G should have, B has 2 number of elements, this has 3 numbers. You don't even have to check all of these things. So it should have 6 number of elements, right? Because all of the elements, B cross G has 6 number of elements, and all of these pairs are in this relation. Because as we've discussed, okay, wait.
Ma'am, you are teaching very fast.
You okay? We know
Ma'am,
that,
but
yes.
the problem is that for given relation, it have a condition. A is the brother of B.
Yeah, so
So
that's
for
what we're
that
discussing.
reason, I think option 1 is correct.
No, that's what we just discussed. See, this person, this covers this option, right? Ramu and Neha, they're siblings. So we have this here. Suraj and Kirti, they're siblings. We have this here. Then we have Suraj and Neha. This has just covered this pair, and we just discussed that they're all siblings. So that means if this just means that R is also the brother of K, no? Wait, give me a second. See, if this person is brother of this person, right? This is a girl, Neha. Suraj is brother of Neha and is also the brother of Kirti. That means these two are sisters, right?
Yes, ma'am.
And this person is brother of Neha. This person's brother of Kirti. That means they're all siblings. They're all brother sisters of each other. So this option that you said only cover these relations and not the other ones. It doesn't cover R and K. It doesn't cover Ramu and Kirti. That should also be in the set, right?
Okay, ma'am, I get it.
Okay. Is it fine now?
Yes, ma'am. Thank you, ma'am.
Okay.
Ma'am, please repeat it.
You just, in this question, the only thing you need to understand is you've been given that this person, Ramu, is the brother of Neha. This person, Anil, is the brother of Kirti. And this person is brother of these, both of the girls, right? So if this person is brother of both of these girls, then they're sisters, right? And if they are sisters, and this person, Ramu, is brother of Neha, then he's also the brother of Kirti. So this pair should also be in the set. And
Okay,
similarly,
ma'am.
AN, this should also be in the set, right?
I got it.
Okay.
Ma'am, I have another doubt. What is injective and surjective function?
Injective is 1-1 function. We just discussed it. And surjective is onto function. We
Ma'am,
discussed that
injective is
too.
another name of one function.
Yes.
Okay, ma'am.
Moving on to the next doubt. Does anyone have any other doubt?
Yes, ma'am.
ma'am. Ma'am, how to find the range of a function?
Okay, you must have gone through the activity questions and all. If there's any question from there, we can discuss that.
Yes, ma'am.
That'd be better. Yeah. Just tell me the question number and we'll discuss that. Otherwise, I'll have to pick up an example on my own.
Ma'am, in practice set,
Which question?
question number 9.
The function is square root of 3 minus x. And I hope you know what this square root function is. The square root, what a square root does is,
Yes, ma'am. Yes, ma'am.
it if you have 4, it takes it to 2. Note that it takes it to 2 only, it doesn't take it to minus 2. The square root of 4 is just 2, it's not minus 2. So if you have square root of 3 minus x, that means you'll have, okay, let's just first discuss the domain of this thing. So the domain for this thing, you can only take the input to be a positive number. This thing needs to be positive in order to calculate the square root of that thing, right? So you need 3 minus x to be greater than 0. That will give you x greater than 3. So you need x to be greater than 3. That's your domain.
Yes, ma'am. Ma'am, I have a doubt in a range,
And
not a domain.
Ma'am, you
Can
wrote
I-
the
yeah,
opposite.
what opposite? This is the argument in this function, no? So this should be greater than 0 and 3 should be greater than x. What's wrong here?
It may be equals to also.
Yeah, that equal to you can take. And then in the range part, so you need the range for root 3 minus x. And range for root 3, okay, range you denote by r. Actually. This is the positive real numbers and y. So in fact, positive real numbers including 0. If you'll put a 3 here, you'll get a 0. And why so? Because let's just start with this thing. The range of this is this function is positive real numbers including 0. And anything that you have in square root, let's just say, is there a doubt or a query from someone?
Yes, ma'am. Practice it, ma'am. Question number 3.
Wait, in this one, we're discussing this part first. Someone had a doubt in this thing. So is this clear
Ma'am,
now?
how root x came?
I was
Ma'am,
just trying to
please repeat it.
simplify this thing, that's all.
समझ में
Root x
क्या आ
is,
रहा है ये तो बताओ
Ma'am,
जो
here
बोल
in
रहे
this
हो वही रिपीट
question,
कर दो
can I ask, ma'am?
yeah.
So I'm asking that here in this question, if the range is the set of all complex numbers, then the domain we can say as R, right?
Range you don't call it, you call it codomain. Range you don't choose. Codomain if it's complex number and you're not going to discuss complex valued functions.
Okay. So suppose if it is complex numbers, then the domain can be R, right?
Even if it's, let's just say you have your function from R to a set of complex number and your function is root x. Then you can't have negative values here, no. This will never give you a negative, this will never give you a -2.
But we can get output, right?
Yeah,
For
you can get
-2.
output. Yeah.
Then it can be included in domain, right?
Yeah, you can include it in, you generally take the domain to be this for this function. But here you can take it to be R itself. It's fine.
Okay. Okay, ma'am.
And once more time explain how we have to find the domain of the set.
Let's just have a domain or range. Is the range part clear firstly?
Yes, ma'am. Range part is clear. One time, please explain domain.
Okay, the domain is the square root function is defined as if you have a 4 here, you will get square root is basically you get so firstly you need to know that it's only 2. You can't take a -2 here. That's how this function is defined. Though you do say that -2 square of -2 is 4, but the square root of 4 is not -2. It's only 2. This function, it only gives you 2. It doesn't give you -2. Firstly, you need to know this thing. Then the other thing is
Okay,
you need to
ma'am.
know the domain of
Why? Ma'am, why?
why. This is how you define the function. This is a function, and this is how this function is defined. So if you have a function root x, this just means a number y such that y square is equal to x, but you have to make sure that your y is the positive one only. Because if y square is x, then minus y square is also x, right? But you'll only be going to take the positive one here. That's how you define the square root function. Is it fine?
Okay.
Yes,
If you
ma'am.
have square root of if you have square root of 9, then it's only 3. It's not -3. This is not the case. That's how you define this function.
But vice
But
versa is
ma'am,
possible. -3 into -3 is equal to 9.
What I'm saying, this function is not the inverse of square function. Not getting into the inverse functions though, because you have those concepts in later weeks. We're not getting into the inverse concept right now. We'll discuss once we'll discuss inverses and everything. So this function, you define it in this manner only. So when you see the square root function, it means that you'll only have positive values. That's why your range is r plus union 0. That's why we don't have negative values here. Is this fine?
Okay, ma'am. It
Yes,
is.
ma'am.
Range part's clear, right? And about the domain part, you would want this thing to be greater than 0.
Ma'am, why to put 0 in range while R positive union 0?
Because r plus does not include 0, and you can have 0 here. If you'll put x equals to 3, you'll get 0. If you'll put a 3 here, you'll get 0. So that means 0 is in the range of the function. That's why it should be included here.
Ma'am,
And
can
for
I
the
say
domain
if
part, yes.
Ma'am, can I say the range is the square root of every function of the square root? The range must be positive.
It's not always the case. When you take square roots, what happens is the inner function also matters.
Ma'am, actually,
If you have something
function.
simple, then it's fine. But if you have something like sin x or something else, or then you can't say that the range is real
But
numbers like r
in general,
plus.
in normal functions without the trigonometry, in normal functions in the square root, so range is the positive.
The range is always positive, that's true, but it's not r plus union 0 all the time. You can't be sure of this thing.
Okay, 0 not
It's
positive
a
because
subset. It's a
okay,
subset of this thing. The range of this function fx. That's what you're asking, right? Let's just say this is a function gx. Then the
okay,
range of this thing is a subset of range of gx is a subset of r plus union 0. That's true. But it's not equal
okay.
to this. It can be equal, can't be equal.
Yeah,
Can't
Ma'am,
say.
you can take a simple example like x square plus 2.
Yeah, you can take that too. X
Uh,
square plus 2, because what happens is this doesn't cover the. We will be discussing ranges and everything in the coming weeks, but we'll discuss it here too. What happens here is the range of this thing, if you just consider this function, then the range is only r plus. But no, this is because it's not even r plus, it's this thing. Because you don't have anything from 0 to 2, that's why. Sorry,
Ma'am, can you please solve this?
solve what?
Yes, ma'am. X square plus 2, ma'am. How do we define domain and range of square root?
Shivam, turn off your mic.
Ma'am, no root x square plus 2, only x square plus 2.
You want the range of this thing?
Ma'am, domain and
Yes,
range
ma'am.
both.
Yes,
We
ma'am.
discussed the range of this. No, this is if you will have
No,
x
ma'am,
square,
square
because
within a
x
square
square
root.
is, yes.
X square plus
What's
2
the
in
doubt?
square root.
We're not discussing ranges, and that's not in week 1. You will have that in later weeks. We'll discuss it there.
Okay,
मैम तो क्वेश्चन जैसे मैं अभी प्रीवियस क्वेश्चन था उसमें डोमेन पूछा था, तो मैम फंक्शन देके डोमेन पूछेंगे ऐसा कुछ?
Yes, but it's not in this week. That's what I'm saying. You will be given functions, you
मैम
will be
क्वेश्चन तो
asked
मैम
range,
एक्टिविटी क्वेश्चन
domain.
मैम और प्रैक्टिस असाइनमेंट में मैम क्वेश्चन ऐसा है कि डोमेन दिया हुआ है और उसमें सॉरी फंक्शन दिया हुआ है और डोमेन पूछा है, तो मैम
Which
क्या क्या पूछ
question is
सकते हैं?
it?
मतलब मैम
Please let her
प्रैक्टिस
Question.
finish.
असाइनमेंट जो
Please
मैम
let her
ग्रेडेड
finish.
प्रैक्टिस। ओके
Can we move on to the next doubt?
यस मैम। मैम प्रैक्टिस असाइनमेंट का क्वेश्चन नंबर 3 और 8 नॉन ग्रेडेड असाइनमेंट।
Question number 3 is not based on, okay. There's one more option to it. So,
मैम कैन यू expand more it? Can you zoom more?
is it visible now?
Okay, yeah.
So we've been given the set of A is the set of even natural
Ma'am,
numbers.
fourth option is not.
Yeah, I couldn't just take it in the screenshot. I'll just draw it. Fourth option is this. This is your fourth option. So you've been given that A is a set of even natural numbers and 0 is included. So it's 0, 2, 4, and so on, so on. B be the set of odd natural numbers. It's 1, 3. C be the set of all natural numbers which divide 100. So it's the divisors of 100. Divisors of 100 are 1, 2, 4, then 5.
5, 25, and 50.
10 is also there.
Yeah.
20 is also there. 25 and 50. This is it, right? And 100 is also there. 100 is also a divisor. This is the set. And B is the set of all prime numbers less than 100. So we're not going to list all of them. Which of the following are correct representation of the sets? So this one says that D set is contained in B. So D set is the set of prime numbers. B set is the set of odd numbers. But we have 2 here, which is not an odd number. So this option A can't be correct, right?
हाँ ठीक है।
Okay. Then coming to the second option, this one says that A and C have something in common. A set is this, even numbers, and this. So they do have something in common, right? A and C have something in common. C and D have something in common. They do have something in common, right? This we have odd numbers here.
Only 2
25,
common, ना?
5.
B and C
You
में
just
only
need
two
to
common.
check. You don't need to check what's common. You just need to check if there's something common or not. That's it. Because they
Okay.
have shown that A and C has something
Okay. Okay.
common. So you just need to
Okay.
check
Okay.
if A and C has something common or not. Similarly, you need to check C and B has something common, which is true, and A and B do not have anything common, which is also true. So the second option is correct. Although it doesn't have D set, but that's fine. And then in this option, it says that D and C has something common. So D is this set, prime numbers, and this is it. So they do have common elements here. So that's also true. C is also true. And then the last one, this one, A and C have something in common. So A is set of even numbers, which is true. We've already checked A and C have something in common. And C and D also have something in common. This is also true. So the option should be correct as well. Is this fine?
Ma'am, please explain
But
that.
Ma'am, A and D, ma'am, please, A and D.
Okay. Option A says
Okay. Okay. Oh.
that, okay. Is it clear
No,
now?
ma'am. मैम एक मिनट मैम ऑप्शन 4 में ए में 0 2 है और डी में 2 से स्टार्ट हो रहा है ना
Okay, we didn't check for A and D, right? A and D's intersection we didn't check, so they do have common, right? 2 is common here,
Yes.
so this is incorrect. Okay, thanks. So these two options are correct then, B and C.
Ma'am, please, ma'am, explain the option 2 again.
Option 2 is, this option says that A and C has something in common, C and B have something in common, and A and B do not have anything in common. And this doesn't say anything about C. So you just have to test if this is true or not. So if you look at A and C have a common element 2. Even if you see only one common element,
मैम
this means
आल्सो
A and
मैम
C. Yes.
मैम इनसाइड मैम ये जो मैम जो बी है वो पूरा बड़ा वाला गोला है ना इट्स अ लार्जर सर्कल
Which one? In option A, B, which one are you talking about?
option A.
Yeah, B is the entire one.
So inside the B, D is present. Okay.
Okay.
So 1, 2. What is the B? The B is set of all odd numbers, and what is the D? D is
set
all
of prime
numbers.
numbers.
Okay. So, okay. तो मैम सभी odd number के अंदर सभी prime number आएंगे.
They won't be there. No, all prime numbers are not odd numbers. That's why this isn't true. 2 is a prime number, but it's not an odd number.
सारे prime number odd number के अंदर आएंगे ना?
No, that's not
It is
true.
not necessary, ma'am.
Ma'am,
2 is an even number,
9 is an
and
odd
it's
number, but not a prime number.
yeah. That's why this option is not true.
Ma'am, you were explaining the option 2.
Coming
I
back to
take the
option 2,
second option
Question
in
number
third
8.
option.
मैम और question
we'll
number
first
इसी
discuss
practice.
option 2, and then we'll move on to the next question if you have any. So in
Ma'am,
second
I
one,
have a option 4 doubt.
Ma'am, I take the second option and third option.
does anyone have a doubt in any of the options? We'll discuss
Ma'am,
the
you were
option, otherwise
explaining the
we'll move
option
on.
2.
Option 4.
Ma'am, option 4.
Why it's not
Someone had,
true?
okay, everyone, no one will talk now. We were discussing option 2. Is there still a doubt in option 2? Someone had a doubt in that.
Yes, ma'am, you were explaining, but you didn't
Okay.
complete
Yeah.
it.
So A and C, A is the set of even numbers, C is the set of divisors of 100. So if you look at A and C, you have 2 as common, right? You don't even have to check for other elements. You can see 2 is common. That means A and C have something in common. That means this situation is true. Then you will check for C and D. C and D have something in common, which is 5. So this is also true. And A and B do not have anything in common. A is set of even numbers, B is set of odd numbers. And the joint sets. That's why this thing is also true. A and B not having anything in common is also true. That means this diagram is the correct representation of this situation.
Okay, ma'am. Thank you, ma'am.
Any other doubt from this part, from this question?
No, ma'am.
Ma'am, option 4.
Yes, ma'am.
Why
I have
it's
a
not?
doubt.
Yeah, what's the doubt?
मैम ऑप्शन फर्स्ट में ऑप्शन ए का राइट साइड में जो है मैम वो फिर से नहीं मैम उसको मैं अलग से ड्रा करके समझा दीजिए बी एंड डी को मैम
Okay.
Okay.
This is B and this is D, right? This set is D and the bigger one is D. So B is the set of odd numbers. It's 1, 3, 5, and so on, so on. And D is the set of prime numbers, which is 2, 5, 7, 3, 7. We're not listing all of them, but that's the set. So you have two here. This option suggests that D is contained in B. This is what it suggests, right? But D has 2, and 2 is not in B. That means this thing can't be true. That means this option is incorrect.
अच्छा हाँ गलत है ओके ओके मैंने ट्रू मार्क कर लिया था उसको इसलिए कंफ्यूज था
Okay.
Ma'am, in option 4, is A is something common with D?
A does see A is this set and it has 2. And D also has 2. So A and D have something in common, but this situation, this Venn diagram says that A and D do not have anything in common, right? That's
मैम
why this
एक्चुअली
option is incorrect.
Yes, ma'am.
सॉरी मैम बट एक्चुअली इसमें जो मैम जब उसको सबमिट पे क्लिक लो तो क्लिक करो मैम तो कुछ ऑप्शन मैम गलत दिखाते हैं जैसे ऑप्शन शायद उसमें ऑप्शन 4 को रॉन्ग कंसीडर किया हुआ है
Option 4 is incorrect here. This is an incorrect option
व्हाई
because A and D, as per this situation, A and D have 2 in common. But your Venn diagram here says that A and D do not have anything in common. That's why this option is incorrect.
Okay.
Ma'am, in option 1, ma'am, A and D elements do have common elements, ma'am, and so ma'am, why they are not included?
Which one?
Option A, ma'am, A and D do have two common elements, two. So ma'am, why they are
This
not?
option is incorrect. Option A is incorrect. This is not the
Ma'am,
correct Venn diagram representation of this situation. That's why you will see inconsistencies here in the diagram.
और मैम ये जो स्क्वायर है ये रिप्रेजेंट कर रहा था यूनिवर्स को मतलब
Yes, this is the universal set, which means everything that's in the situation.
मैम लेकिन मैम ऑप्शन 1 में ए और डी में मैम टू टू दोनों एलिमेंट कॉमन आ रहे हैं मैम मैम फिर उन्होंने मतलब इंक्लूड क्यों नहीं कर रहे अपन मतलब अलग क्यों किया अपन ने
Option A is incorrect. That's why A and D, you're saying A and D has something common, but this diagram says that A and D do not have anything common. That's why this option is incorrect.
Okay. I got it.
This also says that D is completely contained in B, which is also not true. So there are a lot of reasons why this option is incorrect. You just have to figure out one reason to disprove this thing. That's it. You don't have to look for every inconsistency there. Shall we move on to the next question?
yes sir ma'am
Yeah.
ma'am
What's
question
the next
number 8
doubt?
question number 8
Yeah, 1 second. Is the question visible?
Yes, ma'am.
दिख रहा हाँ दिख
Okay.
रहा है
So the question says, you have been given a relation where you say that A and B are related if both A and B are even non-zero integers and A divided by B is an integer. This means that B divides A. This is the notation that we use for B divides A. I don't think you guys are familiar with this notation, but this whole thing just means, so the relation here is AB such that A and B are non-zero integers. And B divides A, right? This is what this thing means.
b divide means a b upon a no
Yeah, if you have A
a
by
divide
B
b
and
means
you
b
get an
upon a
integer here, if you have A by B and this results in an integer, that means B divides A. If it doesn't result in an integer, that means B does not divide A. Is it
what
fine?
ma'am a upon b means b divide a मतलब okay no ma'am opposite relation है ये actually
this says that if you divide A by B, you get an integer, right? Which means that B divides A. Let's just say you have 4 and you say that 2 divides it, you get, so what you get is 2. Because this is an integer, that's why you say 2 divides 4.
Okay.
If you had 3 here, you would get 1 point something. So you won't get an integer. That's when you say 3 does not divide 4, right?
Yes, I can understand. But why you written left side, upper left corner, upper right corner B by A?
That's what I was telling you. You don't have to pay attention. This is the mathematical notation for B divides A. This is not the same as this thing. This notation is different. This is this.
This
We
is
generally
minus ना
use
B
this.
exclude
You
मतलब B
forget
स्टेटमेंट
about
में
this
A
notation.
को exclude कर दो.
Yeah, you
इसमें
forget about this notation. This notation is not important. You won't see it in your assignments. That's why I've written this thing here. B divides A. Is this part fine? So to
yes.
check if this relation is reflexive or not, let's just say you have B divides. This is not always true, right? If B
Four.
divides A,
No, ma'am. It's not reflexive.
if B divides A, then A might not divide B. For example,
Okay,
this
ma'am.
one, right? So this is not a reflexive relation. No, for reflexivity, you check the same thing, right? We check the symmetry. So this is a reflexive relation because every integer divides itself, right? So this is a reflexive relation. Option A is correct. Then this is not symmetric because, as in this case, 2 divides 4, but 4 does not divide 2. So this option is incorrect. Then you have transitive relation. So let's just say A divides B and B divides divides C. So this would mean you'll have this. We can prove
Transitive.
this thing, but it's a transitive relation.
It's transitive.
Then
The
C
proof
divide
is
A.
very simple. If you want to prove this thing, you can just do A divides B. So you can just say that. Wait.
Ma'am, take example 64, 128, and
So
256.
examples are different when you prove things and when you say. So if you are you'll have to prove things. Not in your exam. In this one, you just have to take the
But
correct option while doing things.
but मैं अच्छी तरह के समझ पाऊंगा ना मतलब it does not matter what is come in the exam. It's not responsible for you
Okay.
कि आप एग्जाम में पास हो या
That's
फेल.
why I was gonna prove this thing here.
Okay, please give me example.
And this is the example. Listen, the
64,
example
128,
doesn't prove
256.
things.
Okay.
Examples are not meant to prove things. They just adhere to what is said. That's what it is. You can't prove facts by examples. That's why I was trying to prove things here. I was going to prove why it's a transitive relation. But you only want an example for it, so we can do that here. If that's the case, this means 64. Okay. Just not use this symbol. Divides 64 divides 128, and let's say 32 divides 64. So anything that divides 64, let's say 32, it also divides 128, right?
Yes, ma'am.
I was going to prove it for arbitrary numbers. But let's just skip that part. This is correct.
Ma'am, लेकिन वो अगर
And then this is not an
128
equivalence relation.
क्या? Ma'am, 128 by 32 is not same as 64 by 32. So it's not a transitive.
That's not the point. The relation defined here is, your relation is A is related to B if A divides B. That's all.
Okay.
The quotient doesn't matter here.
And also, if A C, then C divided by A divided C.
That's what we said. No, if A divides B and B is related to C, this would mean that A is related to C. A divides B, B divides C, that means A divides C.
Okay. और मैम जो आपने जैसे A डिवाइड B लिखा था और A डिवाइड बाय B, अगर 20 को A से भाग करेंगे तो इंटीजर आना चाहिए, तो आपने A इज इक्वल टू A कैसे लिख दिया? मतलब A को A से डिवाइड करने पर भी इंटीजर आएगा अगर हम A को B से डिवाइड करने पर इंटीजर आता है.
What are you talking about?
मैम मैं कह रहा हूँ जैसे आपने A करके लिखा ना, A B के जस्ट लेफ्ट में A upon A लिखा. What is mean?
This means that A, when you This doesn't mean anything. I was just trying to write A divides. This is for the reflexive part. A divides A. This is
तो
not the
वही तो मैं
notation for A divides A, but this is what I was
I
trying to
know
say.
this is
A
the notation
divides
for
A.
A divided by wait. I know just it is a notation for A divided by A divided by A, uh but can you explain please मैम उसमें तो A upon B दिया है ना, तो A upon B को हमसे
What is the
हम क्या
definition
रिलेशन
of a reflexive relation?
ओके
What's the definition of a reflexive? Anybody who can tell what's the definition of a reflexive relation?
मैम की तो A इक्वल होना चाहिए.
No, that's not how you define it. You define it as
Actually okay मैम
A is related to A. That's how you
okay.
define it. That A should be related to A. And the relation here is, we say that AB is related, or you say that A is related to B if A divides B, right?
Okay.
So A is related to A if A divides A. That's what you have to check. Doesn't every number divides itself?
Okay.
That's why A is in the relation. It's fine now?
हाँ A divided. तो मैम ये रिफ्लेक्सिव तो ए होगा ना, ए बी कैसे होगा? अच्छा समझ आया, ठीक है समझ में आ गया, ठीक है. अगर 4 को 2 डिवाइड करेगा तो 2 2 को भी डिवाइड करेगा, ठीक है, वो इंटीजर होगा, ठीक है. बट
Any other doubt from here? Yes.
मैम कोई अगर अदर एग्जांपल लेते हैं तो मैम वो भी इंटीजर होगा क्या? मेरा यही डाउट था इस क्वेश्चन में कि जैसे कोई और डिजिट लेते हैं 2 के अलावा, तो अगर हम किसी को ए मान लेते हैं और जो डिनोमिनेटर में कुछ भी और लिखते हैं बेस में, तो वो इंटीजर होगा. और जो अगर मैम 18/9 करते हैं तो 2 आएगा, और अगर 9/9 करते हैं तो भी 1 आएगा, ठीक है. ओके मैम, थैंक यू.
Okay.
Ma'am, in transitive, every element we fulfill the conditions A into B and B into B divided by C, then is divided by C. Every element check.
Yeah, that's it. We have a proof for it. If A divides B, if A divides B and B divides C, then this implies A divides C. If that's what you're asking, we have a proof for it. We can prove this thing.
Yes, but every element check, or some elements prove that then the
When you
transitive.
prove something, you prove for every element.
Okay, right.
That's why we have a proof for it.
Okay, but
When
in
we say
some
A
cases,
divides,
suppose
let's just
A
do it for
divide.
arbitrary numbers. Let's take A, B, and C to be arbitrary. All right? And let's just try to prove this thing. We're not taking fixed numbers. We're taking A, B, C to be any numbers. Can we do that? We'll do that
Yes,
here,
ma'am.
okay?
Yes, ma'am. Yes.
So if A divides B, that means B is equals to AQ for some Q, right? And B divides C means C is equals to BR for some Q belonging to integers. And for some Q belonging to integers. So R. You have an R here. Is this part fine?
This type
Yes, ma'am.
formula I have not studied in quiz 1 in week 1.
Okay. Let's just say when you have 18 and you say 6 divides 18, right? So what you do is, how do you do it? 18 and it's 6 into 3. If you can find an integer such that 6 into that integer is 18, that's when you say that 6 divides 18. That's what we've done here.
Yes.
We say that A divides B if there is an integer such that AQ is equals to B.
Okay.
We say that B divides C if there is an integer such that BR is equals to C. And now you have to prove this is given to you. This is not something in your course. We're doing it extra here.
Okay. My question is that suppose A divide B and B divide C, then only check A divide C. Only if only A divide B, not B divide C, then not checking.
Yeah, that's what's the definition of a transitive relation. Transitive relation is if A is related to B, the relation here is divides, right?
Okay,
If
yes.
A is related to B is related to C, this should, if these two conditions are satisfied, then you check
Then
if A
only
is
check
related
A
to C
divided
or not.
C.
Yes, then only you have to
Okay,
check.
okay, okay, okay.
Otherwise, you
Okay, okay.
don't.
Right.
Okay.
मैम कैन आई आस्क समथिंग?
Yes.
मैम प्लीज मैम, जो फंक्शन होते हैं मैम, इसको थोड़ा सा डिटेल में बता दीजिए, मतलब ऐसे ब्रीफ में बता दीजिए, जो रिफ्लेक्सिव होता है और जो अदर फंक्शन होते हैं। और मुझे कंफ्यूजन होता है ऑन टू में और रिफ्लेक्सिव में, दोनों मैम सेम ही फंक्शन लगते हैं मुझे, मतलब सर्जेक्टिव, और इसमें मुझे आई एम न्यू इन मैथमेटिक्स, एक्चुअली मैं बायो बैकग्राउंड से हूँ तो।
Okay. On to subjective, and what were the other things that you were saying?
मैम सारे फंक्शन,
Reflexive.
मतलब दोनों चीजों को, मतलब ये फंक्शन और जो वो ऑन टू वगैरह सर्जेक्टिव, और वो क्या कहते हैं जो एक्स से स्टार्ट होता है।
Okay. When you discuss about onto,
यस
surjective,
मैम,
and then
रिफ्लेक्सिव, यस मैम, यस मैम,
and then
ट्रांजिटिव,
you have one.
यस मैम,
This is
एंड
generally
ट्रांजिटिव
used in
आल्सो।
terms of functions. Yeah, we'll get to that. So when you
यस मैम,
discuss about functions, that's when you talk about these things. Onto, surjective, injective, one.
यस मैम। और व्हाट इज रिफ्लेक्सिव?
That's generally when
इट इज फंक्शन, एंड व्हाट इज रिफ्लेक्सिव क्या है मैम?
this is used in terms of relations. It's
यस मैम,
reflexive,
मैम
we
रिलेशन,
use in
ओके,
terms of relations.
ओके मैम,
Relations, you have,
हाँ,
so when you say these terms,
ओके,
you're talking about relations.
ओके मैम,
So on to, we'll discuss with the relations first, because relations, functions are also relations. So we'll start with relations. You know what relations are, right?
ओके मैम, यस मैम। नो मैम,
Okay,
इसको
so
थोड़ा ब्रीफ में सभी को समझा दीजिए मैम, फंक्शन और रिलेशन को भी मैम, रिलेशन, ओके,
relation
ओके,
is, let's just say you have a set A here and you have a set B here. So you define a relation here between these two sets. So you say that there's a relation from A to B. And let's say you have these elements here and these elements here. So relation could be anything, any mapping. You can map this to anything. You can map it to this. You can map it to this. You can map it to this. This is what your relation is, right? So any element from here, you can map to any other element here. That's a
यस
relation.
मैम, ओके मैम,
And you don't have to make sure if every element here is mapped or not. And when you talk about functions, what happens is you have, function is also a relation. In relation, you have freedom to choose how many images to assign to a given element. If you have to assign an image to an element or not, you have freedom there, right? You can choose to not give this any image. You can do that in a relation. But in a function,
ओके,
what you do is, if you have elements here, this is called your domain. You will
यस
have to
मैम,
map every element to some element here.
यस मैम, कोडोमेन,
So you will have to make sure that every element has an image. That's the
ओके मैम,
first condition for function, which is every element in D has image in codomain.
So ma'am, every function does contain relation.
Every function is a relation. It doesn't contain a relation. Let me just get done with the definition of a function first. So firstly, you have to make sure function is a relation, but a special type of relation it is. Where you have to make sure that every element in the domain, every element from this has an image here. First is this condition. And then the second condition is that you have to make sure that every element, no two element has, okay, every element has only one image. That means if you map this to this element, then you cannot map this thing to other element. But you can do that here. In a relation, you can map elements to two elements here, this one and this one. But you of relation, it has restrictions, right? You have to make sure that every element has an image and every element has one image only. It cannot have two images. Is that fine?
यस मैम, मतलब मैम ये रिलेशन की बात हो रही कि हर इनपुट का एक आउटपुट होना चाहिए।
No, this is functions. Function.
ओके,
For a function, every input should have an output.
ओके,
Every element has one image. or you can say only one image. And if you have to combine these two in one, you can just simply say every element in D in your domain has a unique image. Or let's just not say unique, has one image, has only one image. Or let's just keep the wording a little tight so that there is no ambiguity. Every element in D has exactly one image. This is fine.
Ma'am, at least one image. Exactly one image.
मैम इसमें मल्टीपल आउटपुट हो सकता है ना वन फंक्शन पे मतलब डोमेन के
Yes, ma'am. I think at least one image. अच्छा भाई, मेरा माइक ओपन होने पर नॉइज आता है क्या ज्यादा? एनीवन?
नो
No.
ओके.
But we need to make sure that the teacher is having time to speak. Hello, ma'am.
There's some disturbance on my end, so bear with it, please. And so we can, yeah, we were discussing the doubts. Is the function relation part clear?
So ma'am, you are explaining what is function, what is the main difference between function and what relations. So you now explaining relations. So can you brief discuss about types of relation and their definition and their examples also?
Yeah.
Then
So the definition of relation is clear to you, right?
yes, ma'am.
Okay. Then we'll come to reflexive relations first.
Ma'am, but people have some doubts. Ma'am, you write in your board एक्चुअली कि एटलीस्ट एक आउटपुट होना चाहिए इजिली ऑल इनपुट का, या फिर एग्जैक्टली वन आउटपुट होना चाहिए? आपने
See,
मेंशन किया,
in
उसको क्लियर कर दीजिए.
relations, there is no restriction to how many outputs, how many inputs. There's no restriction in relations. But in functions, there is a restriction where you say that every element here in the domain, this is your domain, every element should have an image. That means if there is an element here, this is an element, it should have an image. You
Ma'am,
can't just
you
name it.
written in your blackboard is you written in your screen is exactly one.
Yeah,
Exact.
exactly one image.
So
Exactly
it
one
is.
image means it cannot have zero images, it cannot have two images. Zero image would mean that this element does not have any image. That should not happen. And no element should have two images. So we have clubbed these two conditions into one condition where we say that every element should have exactly one image.
मैम एक्चुअली -1 का स्क्वायर भी 1 होगा और 1 का स्क्वायर भी 1 होगा, तो एग्जैक्ट मैम, तो उसमें दो भी हो सकते हैं ना मैम, अगर एक कोडोमेन लें और फंक्शन
Yeah,
लगाएं
so
तो उसमें.
-1 and 1, so these two elements have the same image.
Okay.
So, but it does. Okay, if you have a square function, you say -1 and 1 have the same image. But that's not the condition for a function, no? A function says that one element cannot have two images, which would mean that one cannot have two images. So if you put one here, you
Ma'am,
only get one.
but you talk,
You get
ma'am,
one image.
but you talk, ma'am, but you talk about the relation. It is a relation or not?
This is the relation.
Okay, but not a function.
X square is a function as well. It's both. That's
We see nothing.
Is
You're
there a
not sharing.
problem? Okay, you can't see my screen. Is it?
No.
Okay.
Yes,
Give me
ma'am.
one
We can
second.
hear you, but yeah.
Yeah, give me 1 second. Is it visible now?
Yes, ma'am.
I hope the screen's visible now. So we've written here, what we've written here is that okay. When you talk about x square, you have, let's just say you have 1 and you have -1 here. So this is your domain. I didn't say that two elements cannot have same image. I just said that one element cannot have two images. That's what I said. That's what this thing means, that it has exactly one image.
So many inputs to one output is possible, but
Yes,
one
this is
input
possible.
to two outputs is not possible.
Yes. So in relation, everything is possible. In functions, one input and two outputs not possible. And in a 1-1 function, two inputs and one output is not possible. So when you say a function is 1-1, you restrict this thing and you say that one element, this cannot happen in a 1-1 function. We discussed 1-1 functions, right? So x square is a function, it's not a 1-1 function because two elements have the same image.
Ma'am, and what if the equation expands to x square minus 2? Just for example, how will find the domain out of it?
Let's say you have this function. If you have to find the domain of this thing, the domain is the entire R, because you can put whatever you want here. You'll get an answer, right?
And ma'am, about the
If
range?
you're talking about range, then your range will be, so your x square is greater than 0, greater than equals to 0, and it's less than infinity. If you do x square minus 2, you'll have this thing. So your range will be this thing. And I have repeated it time again that this is not in the week 1 syllabus. This is in other weeks. So we can discuss the domain and range there.
Okay.
Ma'am, I have a doubt.
Let's just stick to this week.
Okay, ma'am. So, ma'am, please explain the reflexive and other functions.
So a reflexive function is basically, let's say you have A, you have a relation from A to B. So reflexive means, so when you talk about reflexive relations or other sort of relations, you have to make sure that your sets are same. So you have to take your relation from A to A itself, because otherwise you can't have a point here in the relation, right? If you have different sets here, then A might not be, okay, let's just not get into that detail. Your reflexive relation simply means that A should be in the relation. That means A should be related to A. If you have a relation on set A, say, then A should be related to A. That's what your reflexive relation means. For example, let's just say there's a relation of.
Ma'am, if father has two sons, then they are related as एक दूसरे का भाई होगा, दूसरा पहले का भाई होगा. Is like reflexive.
Yeah. So if you have a relation, so brothers, the relation of brothers is only reflexive when there are only males in the set, right?
Yes, ma'am. Can you give me more than 3 example, like in this? इसी तरीके के 2-3 example और दीजिए. Okay. Yes, ma'am. Thank you, ma'am.
So if you have the set of males and your relation is brothers, so we say that one male is related to the other male if they are brothers. Then this is the reflexive relation on the set of males. But on the set of human beings, where you include females as well, this is not a reflexive relation. Sorry. No, this isn't a reflexive relation at all. I was talking about symmetric one. Let's just not take this example here. So reflexive relation means, let's just not take the example of brothers because no one is a brother of oneself, right? So this example won't work here. Let's just say the example of a reflexive relation could be the, let's just say you have less than equals to relation. Let's take this relation. So we're defining the relation to be less than equals to. So less than equals to means, so if you say A is less than equals to B, this means A can be less than B or it can be equal to B. That's what it means, right? So this is a reflexive relation because every element is less than equals to itself because it's equal to itself, right? That's why. So A is equals to itself. That's why A is less than equals to A. So A is related to itself. In this relation, A is related to itself. That's one example of reflexive relations. And then you can have the relation of parallel lines. Let's say parallel, you're defining the relation to be parallel lines. So every line is parallel to itself. If you have studied the concept of parallel lines, this is what parallel means. Whether the distance between these 2 points remains same, the perpendicular distance remains same. That's what parallel lines are. So a line is always parallel to itself. So in that sense, if you have a line L1 and you have a line L2, then if you have a line L1, then because it's parallel to itself, that's why L1 is related to L2 if your relation is parallel. If you're taking the relation to be parallel, then L1 is related to itself, right? That's why it's a reflexive relation. Is this part clear?
Yes,
We've
ma'am. Ma'am,
discussed two
please one
examples for
more.
reflexive.
Yes, ma'am. Please one more, ma'am. Ma'am, yes. And two example is very fantastic. Ma'am, second example very good example.
I can't think of, and we're not left with a lot of time, so let's just move on to the next. I can't really think of another example. We've only left with 12 minutes. So we'll move on to the symmetric one. So in a symmetric relation, what you do is, if your A is related to B, this should imply that your B is related to A. Only when this is true, this should be true. If this is not true, then this need not be true. In fact, it shouldn't be true. If this is not true, then this shouldn't be true. This is your symmetric relation. It goes both ways. So an example for this is the brother example that we were discussing. So if your set is set of males, uh, all males, then the set of the relation and your relation you're defining is to be the relation of brothers. Then this is a symmetric relation, right? Because if A is brother of B, then B is also brother of A, right? But if you will if you will take your set to be set of all human beings, then this is not true. Because then you have females as well. So if you say that A is brother of A is brother of B, A is related to B means A is brother of B, then it's not necessary that B is brother of A, right? Because B could be sister of A. So this is not true. Is this fine?
Ma'am, what is the difference between identity and reflexive relation?
The identity relation is reflexive relations. Basically, if you have the reflexive relation is this thing, right? If you have a set, you need to have this thing here. And then in identity relation, there is a difference, and I don't tend to remember the difference right now. Wait.
Okay, ma'am, no issue.
An identity relation is a subset of reflexive relationship.
Yes, it is a subset of
Wait.
reflexive.
Ma'am,
Okay,
could
yeah.
you also
So
please
oh
touch
yeah, it's a
upon
very subtle difference. A very subtle difference it
Ma'am,
is, which is identity relations. One second. Identity relations. In identity relations, the only elements that you see is A, B, B, and C, C. So
all the elements
this is
have,
the only type
yeah,
of
all the
elements you'll
elements,
see. Yeah. But in a reflexive
yeah, all
relation,
the
you can
elements
have
needs to
something
have the
else.
reflections.
If you have A, B, C, then your identity relation is this A, B, B, C, C. And if this is a given relation to you, then this is a reflexive relation. So you can say that identity relations are reflexive relations. But not all reflexive relations are. Identity implies reflexive. But reflexive relations are not necessarily identity relations. Is it fine?
Yes, ma'am, it's clear.
Yes, ma'am.
Oh, okay.
Ma'am, one.
Anything else?
Ma'am, could you also touch upon surjective and bijective concepts once?
Ma'am, I have a doubt. One thing.
Yes.
You say it A is equal to ABC. Then I have only AA, not BB, not CC. Then is it reflexive or not?
No, it's not reflexive. You need to
No,
have
means
BB. You need to have CC in it.
okay, all
In the
elements have
relation.
to.
Yeah. They all have to be
Okay.
here. You can have extra elements, but you'll have to have these three here.
Okay.
Okay. And about the surjectivity one, uh, surjective functions are just onto functions. Do you want me to go into the definition of onto functions?
मैम कोडोमेन वो रेंज के इक्वल होना
Someone
चाहिए.
has a doubt in this part, surjectivity one.
Yeah, if you could explain with a simple example, please.
Okay. See, let's say you have x square plus, or the simplest example would be x, the identity function itself, where you just take fx equals to x. Now you know that this is a subject onto function. Why? Because if you have R here, if the function is from R to R, then every element here in this set has a pre-image, which is the element itself. So if you have two here, the pre-image will be two, right? So this is the simplest example of an onto function. Moving on to other examples, let's just say you have we can do it with the help of a graph or something, if that's okay. Because
Yeah, I did go through the video which explains the parabola and that only the positive range of a square is onto, and the negative side of x square, I mean the minor series, is not.
yeah, so is it okay if I give an example in terms of a diagram, a function's graph only?
Yes, please.
We discuss in terms of graphs. If you see, let's just say you don't even have to do this. Let's just say you have fx, every line. This is not in the first week. Let's just say you have 2x. This is also an onto function. In fact, 2x, if every function of this form ax, where a is not equals to 0, is an onto function. You can even check this. Let's just say you have ax, and onto function is that every element, and this is the function from R to R. So what you can do is you can take an arbitrary element c from here, and you can find the value of x such that ax is c, right? So if you'll take x equals to c by a, you'll get ax equals to c. That means this is an onto function.
मैम
This
आपने
part
कितनी
clear
बारी
to everyone?
2x is onto function or into function?
2x is that's what every function of this form where a is not equals to 0 is an onto function. This is an onto function.
मैम C upon A, then what the next step, then what, कैसे
Okay,
जान
what you
पाए
do
कि ये
is
subjective है?
in an onto function, let's just take a simple example, fx equals to 2x. We have fixed the value of a equals to 2. This works for any a, but let's just take 2 in particular. So if you have 2x, what does onto mean? Onto means if your function is from R to R is your codomain. We take any arbitrary number from here, c, and we try to find the value of x such that fx equals to c. right? That's what you want. So if you get an x such that fx is equals to c, that means this function is onto. So you need to find x such that fx is c, or you can say x such that 2x is c. So if you take x equals to c by 2, if you put x, so if you will find the value of c by 2 of this function at c by 2, you'll get 2 into c by 2. So you'll get c, right? Choose any
Okay.
arbitrary real number and we can find a number such that fx is equals to c.
Okay,
You
ma'am.
give me an arbitrary number.
Okay, ma'am. Suppose, ma'am, why we takes c? Why not takes directly c? If we take 2, then x is equal to 2, then 2 is equal to 4, then c is equal to 4. तो मैम पहले मैम सी को कैलकुलेट एक्स को कैलकुलेट क्यों करे सी के बेस पर रख के मतलब सी बाई 2 इज इक्वल टू 2.
Because we want to find the value of x such that fx is c. Let's just say you want to find, what does onto mean? Onto means that if there's any element here, we've taken an arbitrary element c. You can take any number. Let's just say I want to take 1.5. I want to see if there is an element x here such that fx is equals to c. So you need to find x. X is missing such that fx is equals to 1.5. That's
Ma'am,
why we are, yes.
0.75.
I think onto function is a range equal to codomain.
That's what it is, range equals to codomain. That's the definition. I am trying to tell you how do you find it.
Okay, ma'am. Okay, ma'am. Carry on, ma'am.
And we are not, I've decided we're not going to discuss about we have a separate week for onto 1 1 functions. You just need to know the definition of 1 1 and onto function for now. That's enough for this week.
Ma'am, then what happened? 1.5 upon x 1.5. मैम अगर 2x फंक्शन होगा तो 1.5 we take just arbitrary number 1.5
You
and then
tell me the
1.5.
value of x. Wait, hold on. You tell me the value of x such that 2x is equals to 1.5.
मैम 0.75. Sorry.
Which
हाँ
is
सही है
1.5 by 2, right? This is the
हाँ
value. That's how you check
तो
onto,
मैम
but you don't have to
तो
worry
मैम
about that right now.
ओके तो मैम 0.75 क्यों ना मैम x की वैल्यू क्यों नहीं ले लेते हैं ना मैम c की वैल्यू निकाल पहले c की वैल्यू कैलकुलेट करेंगे देन x की वैल्यू निकालेंगे तो मैम c की वैल्यू मैम
We're
x की
trying
वैल्यू
to do, yeah, we are trying to do it for an arbitrary constant because you can't just check for 1.5. No, can you check for all real numbers? Is it possible for you to put every number
no
here and
no
then try
मैम
to test for it?
no मैम
That's why
बट
we have
एक्चुअली
taken
हमें
an arbitrary number c.
ओके
If it's true for every number, this represent any arbitrary means every real number you can take. You can take any real number that you want.
मैम तो वही तो मैम पूछना चाहता हूँ कि अगर हम आर्बिट्री लेंगे तो क्यों ना x को ही मान ले हम कम हमें बहुत
X
कम
is
कम
here, no.
कैलकुलेशन जी
If you will take 2x equals to x, then you will cut it. You cancel these two things. It will create confusion. You can't take x here when you already have x.
Ma'am, sorry to interrupt
2x
you, but hello.
Yes,
If we define function fx is equal to 2x for n to n, then it will also be the one-one function.
fx equals to x.
Fx is equal to 2x, which is defined into n to n
What's your question? Do
natural
you want to
numbers.
ask if it's a 1 1 function or not?
No, if we define it for natural number to natural number, then it will
Okay.
be 1 2 or not.
If you define it for natural number to natural number, then it's not
Yes,
okay. Then you're asking if it's an onto function or not.
yes, ma'am.
And it's not an onto function. One does not have a preimage, right?
Okay.
You cannot have any x in natural number such that 2x is equals to 1. Because only half can give you that value and half is not a natural number. Is it fine now? And we will not discuss anything about 1 1 function. Let's just stick to the syllabus of week 1. You don't have that in week 1. We have a separate week for that. Is there any other doubts from this week?
मैम एक्सरसाइज 1.5 का क्वेश्चन 1.7 का क्वेश्चन नंबर 3.
This is based on the set theory part that we discussed in the start of the session. So
No,
let's
sorry.
say
I think it's sorry. I think 1.6. Sorry, 1.6.
so the question is set comprehension defines squares of. So you have a set where you want the squares of the first 100 natural numbers.
ये भी डिस्कस कर लिया मैम.
Has this been discussed already? Has this
Ma'am,
been discussed in the
oh,
summary session?
okay, ma'am. But sorry, ma'am. But fourth option समझा दीजिए बस.
This fourth one.
Yes, ma'am.
You have to find the set notation for the square roots, the squares of first 100 natural numbers. So your first 100 natural numbers
Ma'am,
starts from
I
0,
don't
0,
understand
1,
the language
2.
written in this option. Ma'am, n square means n square एक ऐसी number होना चाहिए such that n belongs to n a natural number and n less than 10,000 होना चाहिए. I think this is the question. This is the मतलब ये option है ना?
Yes, it should be less than 10,000 and the square of natural numbers that are less than 10,000. This is the set. It's a collection of
तो मैम
square of
इसमें
natural numbers less than 10,000.
तो मैम n स्क्वायर का वैल्यू 10,000 से कम होना चाहिए या n का वैल्यू 10,000 से कम होना चाहिए.
N. It says n less than 10,000, no? So
मतलब हम
n should be less than.
मैम 900 मतलब 900 9,999 तक की वैल्यू का.
Yes, the square till this part. Starting
Okay.
from 0 square, 1 square, 2 square, and you'll end here.
डॉट ओके मैम एक्चुअली इसमें अभी थोड़ी देर पहले सेशन हुआ था तो उसमें सर ने 99 लिया था तो वही कंफ्यूजन थी मुझे 999 लिया था.
You must have taken this one, the second set.
ओके मैम जब हम फोर्थ ऑप्शन में लिया था वही कंफ्यूज कर गया था मैं. ओके मैम थैंक यू मैम.
Okay.
Ma'am, please explain the option third.
What?
Please explain the option third of this question.
I can't hear you. Your voice is not very clear. Hello?
Ma'am, I am saying third option.
Your voice is breaking. Can you repeat your question? Is it related to this question?
Yes, ma'am, I am saying that. Please explain the option third.
Option third. See, firstly, one thing that you have to know, this is just something that I'm trying to, it's something extra that I'm telling you, which is that I hope you're aware that only one of the options can be correct. So if you found one correct option, that's only correct. And especially if you see a clear contrast between two options. So if you see this option and this option, they're clearly different from each other. They can't represent the same thing. So it should be obvious, but we'll discuss the third one. This is the collection of the natural numbers. So the n is, this number is in natural numbers and the square root of, this is not even a correct form. This has a form problem.
No, but when we
Incorrect form.
submit the responses, it says this is one of the accepted answers.
It's one of the accepted answers.
So the accepted answers are option B and C.
Okay, that works too. This is basically n. Okay, works. It's fault on my part. Sorry. It's the collection of natural numbers such that the square root of that natural number is in natural numbers. These are conditions, right? First condition on this number is that it should be a natural number. Second condition is that the square root of it is also a natural number, and the third condition is that this should be less than 10,000. Right? Why does it represent it? This looks very different from this, right? But they do represent the same set, which I
Yes, ma'am.
initially said didn't, but they do represent the same set. Why so? So 10,000, this is basically n less than 10,000, which means n is from starting from 0 and it ends, right?
So root 10,000 is equal to
So if you
100.
take square root of n, you will get 0, and this is not equal. You will get 100 here, right? What you want here is, it's the collection of natural numbers. So the square root of that natural number is also a natural number. And the natural number you have to take from 0 to 10,000. So if your n is from 0 to 10,000, your square root of n is 0 to 100, which is the same as this option, right? If you will replace n square with n, and then you'll have to replace this n with square root of n, isn't it? Let's just look at the option 2 only. N square, n is in natural numbers, and n is less than 100. Let's just make slight changes to it. Instead of this, let's take n only. We're writing it in different formats. Then you will have square root of n belonging to n, right? We've taken square root here, and then you will have square root of n
Belong to 10,000.
should be less than 100, right? Isn't it the same thing that we have here? Right? This also represents the same set, no?
If roots
If you
come,
will
then
talk
it
about
is
this
10,000.
square root of n is a natural number, and if n is less than 10,000, that means square root of n is less than 100. So this set represents this. This is the same as this set, and this set that we were discussing, this one, which is the correct option, also represents the same set, right? Should I explain it one more time?
Yes, ma'am.
Okay. Let's just start with the correct option. This is the natural way to look at this. The first thing, if you have been given this set and if you have to write it on your own, this is how you're going to write it, right? This is how you write it. N square such that n belongs to natural numbers. This is the natural way to write that set, which is given in the question, right? I hope this part is clear. So now what you do is, and the set that you've been given is something different. It's this. So instead of taking n square, take n only here. So if you take n, first you were collecting n squares, now you're collecting n's. So you were collecting n square such that n is in n square such that n is in natural numbers. Now what you want is n, because you're collecting n such that this is just a notation thing. You can use capital N also. That works too. If this is creating confusion, you can use capital N, but make sure you don't use this because this is the notation for natural numbers. So you can use this notation, capital N instead, where you're taking capital N to be equals to n square, right? Now, if your capital N is n square, then what is your n? It's square root of n, right? So you should write this thing here. Is this much fine? Whoever has this doubt, is this fine to you?
Yes, ma'am.
Okay, so these two sets, you agree that these two sets are same, right?
Okay.
And what now the third option is, your third option is this thing, which is it's collection of n. It's written in a different format, so that n is in natural numbers, square root of n is in natural numbers, and here they've said that your n should be less than 10,000, right? This is what they've said. So instead of writing n less than 10,000, can I not write n square root of n less than 1,000? isn't 100. Are these two things not the same thing? Is it clear?
Yes, ma'am.
If you have n between 10,000 and 0, then your square, we're trying to make it look similar to this because we have this notation, right? Or you can either take square root here or you can take a square here. Whichever looks better to you, you can do that. If you don't want to make changes to this set, to the option that you've been given, what you can do is you can just take in this part you have square root of n less than 100 and greater than 0, obviously. So your n is going to be this, isn't it?
This part is clear.
This part's clear, right? So this you can write as, this set you can write as n such that square root of n is a natural number. And instead of writing this thing, because we want to make it look like option 3, you can take this thing. Is it fine now? And this is exactly the same as this set. The only difference is obviously taking n to be natural numbers, because in this set also, this one, you're taking n to be natural numbers, right? So this is understood, this part's understood. And what's left? And this is just capital N and small n. And as I've said, in set notation, this doesn't really matter. Either you take small n or you take capital N, because this is just a variable. So it
Ma'am,
doesn't
could you
matter what
also
you take.
activity 11, question 1 and 2 before you end the session?
Activity 11, question 1 and 2. Yeah, 1 second. This is the question, right?
Yes, ma'am.
So you've been given a function and you have to find the domain of this function. So you have x plus 12 and 4x minus 8. What do you think are the values that you can put here? And what are the values that you can't put in this function? What cannot be the input? Does anyone want to guess or to try? You have to
Maybe.
put the values of x so that this value is a real number.
So 2 cannot be possible because it would be denominator 0.
You have to make sure that your denominator is not 0. For that, you'll have to make sure that your x is not 8 by 4, which is your x is not 4. So you can't take x to be 2. Every other real number you can take. If you put any other real number, the denominator is not 0. That's why this function is defined. So your domain is going to be r minus 2. Is this fine?
Yes, ma'am.
Okay.
And then you have the mod function. I hope everyone is
Ma'am, is
familiar
it
with the mod
-2
function.
or 2?
It's 2.
-2.
You can't take 2 here. It's 2.
No, ma'am. R upon 2 curly bracket is mean exclude 2, no?
Yeah, this means you're not including 2. These are the same notation. You can write it in this manner or you can also write it in this manner. But in the assignments and everywhere, you will generally see this.
Okay, ma'am. Thank you.
Okay. And then you have to find the maximum of this this function, I guess, the minimum of this function. So a mod function, I hope everyone's familiar with a mod function. A mod function is basically x when your x is greater than 0, or minus x when your x is less than 0. So it simply means if you put a 2, you'll get a 2. If you put a minus 2, you'll get a 2. That's what your mod function is. No matter what value you take, it gives you the the positive part of that value. That's your mod function. And this is how you define that function. This.
Ma'am, please explain mod function. I don't understand, ma'am.
Let's say you have this thing. Mod function means if you will put minus 0.7, you will get 0.7. So this mod function ignores minus sign. It removes the minus sign and makes it positive. And if you take 0.7, you'll get 0.7. So if there is no negative sign, you'll get the same number. If there is a negative sign, it will remove it.
No, ma'am. 9 mod minus x. What do you mean about it? 9 mod x.
This is a function. First, I want to make sure that everyone knows what a mod function is. Does anyone have a doubt in what? Wait, hold on a second. Hold on a second, please. What is everyone clear with the definition of a mod function?
Yes, ma'am. Yes, ma'am.
Okay.
Yeah.
Now we'll come to this
Take the
function. This
absolute
function,
value.
yeah, the absolute value. This function uses mod function. Just as you have 9x minus 8, 9x plus 8, here you have 9 multiplied with mod x minus 8. This is how you define the function. You use mod function here. And then you've been asked the minimum value of this function. So to find the minimum value of this function, you know that the minimum value of mod function is 0, right? That's the minimum value that you can have. So 9 mod x is always going to be greater than 0. And if you take 9 mod x minus 8, then this is always it's going to be greater than 0 minus 8, which means minus 8. So your 9 mod x minus 8 is going to be always greater than minus 8, actually greater than equals to. So this is the minimum value that this function can have. Because this function is always greater than minus 8, that's why this is the minimum value. And when you have equals, what's the difference when we say 9 mod x? If you say your fx is always greater than 0, this means fx can have only values greater than 0. And when you say equals to, this means that there is an x1 such that fx1 is 0. This is what it means. And there are x such that fx is greater than 0. Is it fine?
So for minimum value, we
it's
also always consider less than or equal to.
You don't always consider it, but in this case, let's just say you've not done the mod of the log function. So there are functions where the value cannot be attained. For example, the log function is one of those functions. Don't worry about this function. You will study it later. This is always greater than 0. Sorry. Let's just take the exponential function instead. This is log is not always greater than 0. You will study this function later in later weeks. This function is always greater than 0. It can never have negative value. But in fact, let's just give you something simpler, which you can relate to. Let's just take 2 to the power x. So if you have 2 to the power x, no matter what value you take of x, this is always greater than 0. It can never be 0. So the value 0 is never attained. But here you have mod. In mod, 0 is attained. In this function, 0 is not attained.
Okay.
That's why it's included here. So in this case, the minimum value is minus 8, because that's the minimum value you can attain, right? Is this part clear? How you get
Yes, ma'am.
minus 8?
Clear.
Does anyone have any doubt in this?
How can I get minus 8?
Okay, you start from here. So I hope you're clear with the fact that your mod x is always greater than equal to 0. It's never negative, right? The minimum value of mod x is 0. And this is an inequality. These are called inequalities. So you have inequalities here. And in inequalities, there are some rules that you can follow. You can if you multiply with a positive number on both sides. So if you have 0 and mod x greater than this, and if you multiply 9 on both sides of the inequality, the inequality doesn't change and it stays this way. But if you multiply a negative number, let's just say you do minus 9. Multiply minus 9 on both sides, your inequality changes. For minus 9, it will be this thing, which is 0. This is it. Is it clear? Is this part clear?
Ma'am, second,
Just telling
okay.
you how you can multiply things. You can multiply with 9 and your inequality won't change. But if you multiply with a negative number, your inequality is going to change. That's what I wanted to make clear. And if you subtract 8 from both sides, the inequality is not going to change.
But
So 0
ma'am, if
minus
we
8 is
multiply
minus
it
8.
with 0, wouldn't we get 0 instead? If we multiply it by 0.
If you multiply both sides by 0,
No, ma'am, you multiplied the left hand side by minus 9 into 0.
yeah, so you got a 0 here, no? We have a 0 here and we have a minus 9 mod x here.
Ma'am, but ma'am, in the left side, you have written in the minus 8 there.
I have subtracted minus 8 from both sides of the inequality. This is what I've
बस
done.
मैम यही कंफ्यूजन थी ना मुझे, मतलब इन प्रीवियस वो लेफ्ट साइड में राइट साइड में मूव करते तो -8 हो जाता, आपने दोनों तरफ लिखा था. ओके, ठीक है, आई कैन अंडरस्टैंड मैम. ओके, यस मैम.
So you can add or subtract any number on both sides and
Yes, ma'am.
inequality won't change. So if this is minus 8 and this is this thing. So your minimum value for this function, this is your function, it's minus 8. Is it fine now? And for the other part, there's one more question. This is it. So we'll start with x plus mod 8. We know that this one's a little tricky because of a negative sign. We know that this is always greater than 0, right? And similarly, mod x plus 8 is also always greater than 0. Is this part clear?
Yes, ma'am.
Okay. Now, if you multiply minus on both sides, you multiply with minus 1 on both sides, the inequality is going to change. So it will become this. Is this fine?
Ma'am,
If
what
there is
happened to the 11?
Sorry, what?
What happened with the 11? Where
Only
did it
ma'am
go?
take mod value.
We'll
Only
take
ma'am
it
take
later. We'll add it now. Now we'll add 11 on both sides. So we'll add 11 here, 11 minus mod x plus 8, and we'll add 11 here. Is it fine now?
Yes, ma'am.
Now this looks exactly like what you had, right? So you will get 11. So this thing is always less than 11. That's what you get. So your maximum value is 11. If you will put a minus 8 here, 11 minus x plus mod this. If you will put a minus 8 here, you'll get 0 and you'll get the maximum value to be 11. So your maximum value is attained when you put x equals to minus 8. So the maximum
So,
value here is 11. Here we have minus 8. Yes.
So ma'am, my the trick is कि simply take the जो भी mod के बाहर वैल्यू हो उसको वही टेक कर लो, वही फंक्शन से ग्रेटर होगी, सॉरी लेजर होगी. जैसे मैम 9 mod x ग्रेटर देन और इक्वल टू -8, और सेकंड एग्जांपल में यू कैन आपने 11 लिया, 11 ग्रेटर देन 8x
Start
plus.
with this one. Start with the mod part and then keep multiplying and adding whatever's left. So you start with the mod part and then you keep adding, multiplying to make it look like this. Start with this thing and try to make it look like this one.
मैम कोई ट्रिक नहीं है इसकी, मतलब जैसे आपने यहाँ पे ग्रेटर देन 11 से कम आया यहाँ पर mod x plus 8, और वहां पे 9 मॉड जो ग्रेटर देन 8 आया -8 से, तो अगर माइनस, तो अगर 8 होगा, तो अगर ग्रेटर देन, अगर माइनस होगा फंक्शन में, तो हम माइनस जो कांस्टेंट होगा, मान लिया 8 को हम सी मान लेते हैं, तो कांस्टेंट से ज्यादा होगा, और अगर प्लस पॉजिटिव होगा लाइक 11, तो वो 11
That's
ज्यादा
what
यानी
it
सी
is.
ज्यादा
This
होगा,
function
ऐसा
is always greater than 0. That's why this thing is always greater than -8. This is always greater than 0. This is always greater than -8. That's the trick. That means this function is always going to be greater than -8. Similarly here, you know that this is always greater than 0. So this thing is always less than 11. Because if you have a negative thing here, why this is always less than 11? Because you know that this thing can't be positive, right? This thing x plus 8 cannot be negative. If this
यस
would
मैम,
have been
ऑलवेज पॉजिटिव,
negative,
तो
then it
अगर
would add
माइनस
up.
लगा तो नेगेटिव हो जाएगा, ओके है ना मैम?
Yes.
ओके, तो अगर नेगेटिव मॉड, अगर नेगेटिव लगाकर मॉड मॉड लिखा हो, तो हम हमेशा उससे छोटा मान लेंगे, और अगर कांस्टेंट यानी -8, अगर -8 को कांस्टेंट मान लेते हैं, सी मान लेते हैं, तो अगर नेगेटिव वैल्यू लिखी है, तो उससे, तो हमें हमेशा उससे ज्यादा होगा फंक्शन, एम आई करेक्ट?
If you have a negative in front of your mod, you don't even have to have this thing here. If you have a negative, it's obvious your mod is always greater than 0. So this thing with a negative will always be less than something. It's obvious. If your mod, because your mod function is always greater than 0, so negative of this is always going to be less than something. So you will only have less than something here. You can't determine the minimum value of this because it doesn't have a minimum value. Its minimum value is it goes till -infinity. Similarly, this function goes till infinity because mod x goes till infinity. And here mod x plus 8 minus mod x plus 8 goes till -infinity. This kind, that's the trick. It depends on if you have a minus sign in front of mod x or a plus sign in front of mod x.
मैम, मैम, can I give you a question? Can you just generalize it?
Yeah.
Okay, C plus minus
Plus
C plus minus
minus.
C plus minus.
Is it like this?
Yes. Yes, mod A
What's
A
in the mod?
A into B.
AB? Is it this?
Yes, मैम. मैम, इसको डिफाइन कीजिए मैम.
What do I define in this? There's no fixed variable here. What's the variable here?
Ma'am, suppose A is constant, B is variable, and हाँ ठीक है मैम, B को x मान ली, ठीक है हाँ.
This thing is always going to be greater than 0. Now it depends on this part. That's what I was trying to tell.
Okay,
If
ma'am.
you
तो
have a
मैम
C plus
okay मैम,
this
हाँ
thing,
हाँ.
this is always greater than 0. Right? This thing is always greater than 0. So C plus this thing is always going to be greater than C. So this thing is always greater than C.
Okay.
And if you have a negative thing here, let's say you have this thing. So you know that this thing is mod AX is always greater than 0. Minus mod AX is always less than 0. So you'll have C minus mod A to be less than. This thing then will be less than C. Is it fine now?
Okay, ma'am. Ma'am, wait, just I take a screenshot. Okay.
So should we always assume x to be 0, ma'am, within mod?
We're not assuming anything here. We're just making use of this fact that mod is always greater than 0. That's all. Greater than equals to 0. We're not assuming that x is 0 or anything.
Okay.
Ma'am, can I ask something? Ma'am, can I ask something?
Yes.
मैम, आपने जो कहा था -infinity to A to -infinity जाएगा और +infinity जाएगा, ये कैसे डिफाइन कर, थोड़ा सा एक्सप्लेन कर दीजिए मैम, थोड़ा सा मतलब है ना. Okay.
If you have something like this, let's say you have this thing. So if we know that this has a maximum, this has a minimum value, right? This is always greater than equals to C. This is the minimum value for this function. So you have a minimum value for this, but you don't have a maximum value for this function. because this keeps your mod function mod x keeps increasing. If you increase x, if you take x to be 1, you'll get 1. If you take it to be 100, you'll get 100. If you take it to be 1000, so this keeps increasing. It will never stop. That's why this thing will go to infinity, and this is something that you'll study in later weeks. Let's just not do everything right now. Everything that we've said so far, we'll have to discuss this in later weeks. And with this, we'll end the session because it's already far
and
past the time.
मतलब कि ये हमेशा सी से बड़ा होगा और इन्फिनिटी तक जाएगा, ठीक है। और अगर माइनस होगा सी माइनस ए मॉड एक्स, देन ये सी से छोटा होगा और मतलब सी मैक्सिमम होगा, इसका मैक्सिमा सी में होगा
This is it.
और
In minus infinity. Is this fine?
ओके ओके मैम, मैक्सिमम रेंज सी तक जाएगा और इन्फिनिटी से स्टार्ट होके माइनस इन्फिनिटी। थैंक यू मैम।
Thank you so much, ma'am. I appreciate you extending the session by half an hour.
Yes ma'am, और मैम योर हैंडराइटिंग इज मैम टू गुड मैम। मैम यस मैम, एब्सोल्युटली फाइन मैम। बाकी सब मैम चिड़िया की टांग बना देते हैं मैम, टीचर एनी प्रोफेसर वगैरह।
We'll end the session here if there are no more doubts.
Thank you, ma'am.
Thank you everyone for joining.
Thank you very much, ma'am.
Thank you, ma'am.
Thank you.
Thank you.